Okay, so hello everyone. In this video, we're going to talk about the differences between a gas and diesel engine. Now, be advised, this is not a video about which engine is better, okay? This is not a gas versus diesel. On this video, we are mainly focused on what makes a diesel engine different from a gas engine. Meaning, we're going to look at how each engine functions, okay? And I will try to make this as comprehensive as possible, and as we go along, questions about what happens if you put gas in a diesel engine or vice versa, what makes a diesel engine have a higher compression ratio than a gas engine, what's the difference between an interference and a non-interference engine, why do diesel engines have bigger batteries, which is more fuel efficient, which is more powerful, which is more faster, which is more reliable, will be tackled in this video. And maybe in the end, you'd be able to decide which engine you prefer and let me know in the comments below, okay? So let's start with the fuel because this is where it all begins. Understanding how each fuel burns will lead us to understand how each engine functions. Now, if you don't already know, gasoline is much more flammable than diesel. We would no longer discuss as to how each type of fuel is made, okay? But just bear in mind, gasoline is more like lighter fluid. It is highly flammable and it easily evaporates and mixes with air. Diesel is a much heavier fuel and it's more like the consistency of oil and has lubricating quality. Gasoline has no lubricating quality because it easily evaporates. Now, because gasoline readily evaporates and mixes with air, if I spray gasoline and air inside this jar using this spray gun, okay, and if I will light that up, see, it will ignite. Now, if we do the same for diesel, okay, spray that there, okay, see, nothing. We don't get ignition. Let's try to add some more. Okay, see, nothing, no ignition, because like I've said, diesel is a much heavier fuel. It's more like oil and it does not readily mix with air. So now that we know how each type of fuel behaves, let's move on to how each engine functions. I already have a video wherein I discuss how a diesel engine works, compression, ignition, and all that. So if you want to, watch this one first. That way, you will already have a base understanding on how a 4-stroke diesel engine works. And as you come back to this video, you will see how it compares to a gas engine. But if you don't want to, let's just proceed and just make sure to watch this one after, okay? So I have this illustration for both types of engines. And if you look closely, there is no difference between the two. Now bear in mind, we are looking only at the combustion cycle, okay? Meaning you are to view all this as just one cylinder representing each stroke. 4-stroke engine to complete one combustion cycle. Intake stroke, compression stroke, power stroke, exhaust stroke, one complete cycle, 4-stroke engine, and it's more or less the same for gas and diesel engines. But with each stroke, you will see how each engine differs, okay? So let's start with the intake stroke. When the piston goes down, with the intake valve open, it will suck in air. For a diesel engine, you will just see an open air intake, you see? And it will just suck in air. The more air, the better. On the other hand, for a gas engine, instead of an open air intake, you will see a carburetor with a throttle valve. Now, we will no longer delve into the intricacies of the carburetor, okay? Let's try to keep this as simple as possible. But this is where gasoline is also introduced, something like that. And this is what they call as the venturi, serving as a bottleneck. As the piston goes down, sucking in air, because of this bottleneck, it will create a vacuum in this area. And because of this vacuum, it will suck in gasoline too. And because gasoline easily evaporates, it mixes with the air as it gets sucked inside the cylinder. And the purpose of this valve is to serve as a flap that opens and closes in order to regulate the flow of air that you allow inside the cylinder. Because in a gas engine, a ratio between fuel and air must always be maintained. Too much air, not enough fuel, you won't get ignition. Too much fuel, not enough air, you won't get ignition. That is why also here, you will also have a means to regulate the amount of gas you allow inside the carburetor in order to maintain that ratio. So if you want more power in a gas engine, you just open this valve. Opening this valve will allow in more air, allowing in more fuel, giving you more power. So you see, on a gasoline engine, a regulated flow and mixture of air and fuel is introduced inside the cylinder during the intake stroke. Now granted, newer gas engines have a fuel injection system, and you will have that injector somewhere here before the intake valve, but the injection of fuel will still happen during the intake stroke in order for the fuel to mix with the air. On a diesel engine, intake stroke, only pure air is sucked in. There is no valve to regulate the flow of air, hence a diesel engine sucks in more air than a gas engine. Okay? The more air, the better. Now, just by looking at the two, you can already see which engine is more complicated. Diesel is a much more simpler design. And now we move on to the compression stroke. Now, because diesel engine allows itself to suck in more air during the intake stroke, it is able to produce a higher compression ratio than a gas engine. And this is the reason why, if you have ever wondered, say they are both the same size engine, a 2.5 liter engine, but when you conduct a compression test for each engine, a diesel engine will have a compression of somewhere between 330 to 400 psi per cylinder, but a gasoline engine will only be between 130 psi to 180 psi per cylinder. Now, I will discuss more about compression ratio when we reach the topic of interference and non-interference engines, okay? Now, because a diesel engine has a higher compression ratio, that also means it's more difficult to crank start a diesel engine. That is why diesel engines are prone to hard starting issues, because it's more harder to compress 400 psi than just 130 psi on its gasoline counterpart. Now you can just imagine, if you have a 4-cylinder diesel engine, 4 times 400 amounts to 1600 psi all in all. You try cranking that up, that would be very difficult. That is why, if you have ever noticed, a diesel engine will have a bigger battery than a gas engine. Although they are both 12 volts, but a bigger battery, you will have more cranking amps. I have already made mention of what cranking amps is in this video, so maybe you would want to watch this one too. This is also one of the reasons why, especially in bigger diesel engines like that on trucks, they require a 24-volt battery instead of just 12. Because more volts equals to more power equals it becomes easier to crank start the diesel engine. And it is because of this higher compression ratio of a diesel engine that it allows itself to produce a lot of power even on low RPMs while burning less fuel. And that is why the preferred engine of choice when it comes to trucks, trains, tractors, heavy equipments, ships hauling a lot of heavy cargo over long distances is a diesel engine, because like I've said, even on low RPMs, it can already produce a lot of power. But the trade-off of that is that a diesel engine is much heavier than a gas engine. Because of its higher compression ratio, a diesel engine needs to be tough. Hence, it tends to be heavier, thicker, and almost always you will have a cast iron engine block as opposed to a gas engine. You can have an aluminum engine block which is lighter. However, don't confuse power with speed. Like I've shown earlier, gasoline being more flammable, it burns more faster, hence it can produce more speed. And this is the reason why when it comes to race cars, it will almost always have a gas engine, and when it comes to trucks or semis, it will almost always have a diesel engine. Now we're still on the compression stroke, okay? Now as the piston goes up on a diesel engine, compressing this air to 400 psi, as I've shown in this video, compressing 400 psi produces a lot of heat by the end of the compression stroke, and the temperature of the air would be somewhere between 650 to 800 degrees Celsius. On a gas engine, it will also compress the fuel-air mixture, and as it does, it will mix the air and fuel even better, but only up to more or less 150 psi, and you don't want that temperature to reach and exceed 800 degrees Celsius, which brings to mind the difference between an interference and a non-interference engine. An interference engine is one wherein the valve in the fully open position extends into the area through which the piston travels. By contrast, in a non-interference engine, the valve does not extend into the area through which the piston travels. Or maybe if they would, but they would place a cutout or recess in this piston so that the valve would not interfere with the piston. Simply put, in an interference engine, they might interfere or collide with each other. In a non-interference engine, they won't interfere or collide with each other. This is why it's very important to set the engine timing correctly. Otherwise, if you don't, or if you break the timing chain or timing belt in an interference engine, the piston and the valve would collide, and you would end up with a bent valve, deformed pistons, broken rocker arms, and camshaft bearings, or a little of each. Now, we will discuss compression ratio. The compression ratio for a diesel engine is more or less 18:1, and for a gas engine, it is more or less only 10:1. Now, what does that mean? Say, they are both the same size cylinders, but because a diesel engine allows in more air inside the cylinder during the intake stroke, you end up with more air to compress. Now, for simplicity purposes, in order to understand compression ratio better, we will look at air as a number. Okay, so 18:1, meaning you have 18 times the amount of air, and as the piston goes up, it will compress it to 1. 18:1. On the other hand, because a gas engine regulates the flow of air, you will have less air. Only 10 times the amount of air, and as the piston goes up, it will compress it to 1. So 10:1. So that is what makes a diesel engine to have a higher compression ratio than a gas engine. Now, because interference engines allows for a very tight space inside the cylinder, it will compress the air at a much higher temperature. That is why nearly all diesel engines are interference engines. Now, don't get me wrong, okay? I'm not saying that all diesel engines are interference and all gas are non-interference. But the general idea is, in a diesel engine, you want to compress that air to get it as hot as possible. In a gas engine, you only want to compress that fuel-air mixture so that it will mix better, but not to the extent that it will cause auto-ignition. Now, auto-ignition refers to the temperature the fuel needs to be exposed to in order for it to self-ignite, purely by exposure to that given temperature as opposed to an external ignition source like a spark or a flame. Say, for example, for diesel, if you expose diesel to a temperature of at least 210 degrees Celsius, it will auto-ignite without external ignition source like a spark or a flame. It will just ignite by reason of its surrounding temperature, and that is what you call as auto-ignition. And for gasoline, if you expose it to a temperature of at least 280 degrees Celsius, it will also auto-ignite. That is why, like I've said, although compression still takes place in a gas engine, but you don't want that compression to get very hot in order to avoid auto-ignition in a gas engine. Which takes us now to the power or the combustion stroke. Now, for a diesel engine, at the end of the compression stroke, all that hot compressed air is funneled into a swirl chamber inside the cylinder head. And the purpose is to make the air swirl, because immediately after the piston is about to go down, diesel is injected. A very fine atomized diesel is injected and mixed with the hot swirling compressed air with the temperature of 650 to 800 degrees Celsius. And in the process, it will auto-ignite, producing power, giving you your combustion or power stroke. And because of the self-igniting system, a diesel engine is very reliable. Once the engine has already started running, it just wants to keep going for so long as diesel is being introduced. It's not prone to stalling unlike a gas engine. That is why it's much more easier to drive a manual transmission with a diesel engine as opposed to a gas engine. And also, because of this system, a diesel engine tends to vibrate more. Another reason why a diesel engine needs to be tough and heavier, because auto-ignition could begin anywhere in the combustion or the swirl chamber. as diesel comes into contact with the hot compressed air. But the positive side of this is, for so long as a fine atomized diesel is being injected, you will always have that power. Even if one or two or even three of your 4-cylinder diesel engine is already badly worn out, lowering the compression from 400 psi to 330 psi, still you will have combustion. For so long as the compressed air reaches and exceeds 210 degrees Celsius, you will still have auto ignition. And this is the reason why, even though when the engine is already badly worn out and has a lot of excessive blow-by, a lot of diesel owners would claim that they hardly feel any reduction in power, thereby believing that there is nothing wrong with their engine. Now, for a gas engine, the ignition is done via a spark plug, producing a spark at always the correct time, igniting the fuel-air mixture always at the correct time, producing a much smoother combustion. But the downside of this is, if there's something wrong with your spark plug or your distributor, if you won't have a spark here, you won't have your combustion. So if you have a 4-cylinder gas engine and 1 or 2 cylinders are not producing a spark, you will end up with a poorly performing engine because only 2 cylinders are working. And all that fuel that got introduced inside the cylinder that is not working will just go to waste. And in most cases, you'd be able to tell that your engine is not combusting the gasoline properly if the exhaust that comes out of your tailpipe smells of gasoline. So like I've said, in a gas engine, when you want more power, you simply have to open this valve, allowing more air, sucking in more fuel, producing more power. In a diesel engine, if you want more power, you simply inject more diesel. And because diesel engines already sucks in a lot of air even on low RPMs, and diesel not being highly flammable, that is why a diesel engine tends to accelerate poorly as compared to a gas engine. So in order to produce more power at higher RPMs, it is more common nowadays for a diesel engine to have a turbocharger in order to pump in more air at higher RPMs. On a gas engine, a turbocharger can also be installed, but it must always be before the throttle valve because, like I've said, you need to regulate the amount of air you let inside the engine and balance that with fuel. Okay? A gas engine is a spark-ignited engine, and a diesel engine is a self-igniting or compression ignition engine. So while you need a spark plug in order for a gas engine to work, and a careful balance between fuel and air, otherwise even if you have a spark here, it won't ignite. In a diesel engine, you just need pure compression to heat up that air, and as you inject diesel, it will produce auto ignition. That is why in this respect, a diesel engine is more reliable. But the downside is, it is only a diesel engine that has the possibility to run away. That is why they call this runaway diesel, because it is only possible with a diesel engine. I already discussed what diesel runaway is in this video, so if you're curious, maybe you would want to watch this one too. Now question, if a diesel engine is a self-ignition engine, what is the glow plug for? If a spark plug produces a spark, a glow plug will just glow and produce heat. And this is only intended to help a diesel engine start, especially when the engine is still cold, especially during cold weather. Because upon startup, the engine will suck in cold air. And this glow plug will heat up, and it will just help the compressed air to heat up faster in order to induce auto ignition. So once the engine is running, the relay for the glow plug will shut off. So a glow plug's purpose is only to help the diesel engine start, especially during cold weather. But you don't actually need it to keep the engine running like the spark plug on a gas engine. But like I've shown in this video, and also in this video, and also in this video, if your diesel engine has good compression and good fuel delivery, your engine should start even without glow plugs. So for the exhaust stroke, both engines work the same way. The exhaust valve will open. As the piston goes up, it will push the smoke out. Now what will happen if you put diesel in a gas engine and vice versa? Now assuming if your fuel tank is empty, if you put diesel in a gas engine, it will most likely not start. Because like I've shown in the beginning, diesel does not readily mix with air unlike gasoline. Hence, you won't get ignition via a spark. On the other hand, if you already have gasoline in your tank and you mix it with diesel, that will lower the octane level of gasoline, and your engine may start but it will perform poorly and it will produce a lot of smoke as it burns the diesel. Now, if you put gasoline in a diesel engine, regardless if the tank is empty or not, the engine will start but it's going to run violently and produce a lot of engine knocking or secondary explosions. Because gasoline is more volatile than diesel, a violent auto-ignition could begin anywhere in the swirl chamber. It is equivalent to introducing lighter fluid in the engine like I've shown in this video. And you will hear a violent sound like a blub 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 blub, something like that sound. Okay? So whenever you make the mistake of putting the wrong type of fuel in your vehicle, regardless if it's gas or diesel, the best thing to do is to drain the fuel tank empty. So anyway, in general, those are the differences between a gas and diesel engine. There is still one difference that I have not mentioned, which is the crankcase vent and the PCV system. But I feel that this topic needs to be discussed separately because this is often the source of confusion. Does a diesel engine have a PCV, or more importantly, a PCV valve? So in order for us to understand this better, I will make a video regarding this separately. So all in all, I do believe that's it for this video. I would just like to remind you, or if you're new to my channel, to inform you that I'm not a professional mechanic. I'm not even an engineer. I'm only a DIY enthusiast. You may believe what I say or not, it's up to you. And I'm only sharing with you what I know and explain it to you the best way I know how. I'm not really computer savvy with video editing and animation, so I apologize for that. But if you found this video helpful and informative, let me know in the comments below. Like, share, subscribe if you want to. Only if you want to. And as always, thank you for watching.